This is a video presentation of Chapter 3, Section 9, which is entitled Multiplying Fractions and Mixed Numbers. So we've gone away from adding and subtracting that we've covered in the last couple sections to multiplying now. And that's actually a good thing because multiplying, and the same will be true for dividing, does not require us to get a common denominator. So because we don't have to do that, we will probably save a lot of time and steps in solving these questions. So let's jump right into this one here. We're supposed to multiply in example 1 and write the answer in simplest form. And it says negative 12 times 3/4. Now what you're going to probably want to do here is, because this is really about multiplying fractions, is you want to make sure that both parts are indeed fractions. And in this case, that means writing the negative 12 as a fraction, which is negative 12 over 1. Now at that point, we would then go ahead and multiply. We would multiply across. So you could do 12 times 3, 36, and 1 times 4, which is 4. So you would have negative 36 over 4. Notice the negative that was in here just got taken right into the answer. Realize that also the sign rules for multiplying and dividing would be the same still. So if there was another negative here, the negative and the negative would wipe each other out, because a negative times a negative would become positive. So here we would have negative 36/4 going that way, and then we would have to reduce because the directions ask us for simplest form. Now what you can see on the screen is a little bit different, even though the process at the end yields the same result. What they're doing here is they're actually reducing first. What you would do is reduce any fractions, obviously, that you would or could. For instance, if this said 6/8 here, I understand it does not, but let's pretend for a moment it said 6/8. You could reduce the fraction 6/8 down to 3/4. Okay? But then what you would do is you would look at the diagonals, and you would identify any greatest common factors in the diagonals that are not 1 and chop that greatest common factor out. Now on the diagonal with 3 and 1 here, the greatest common factor is 1. So that means nothing can be taken out. But on the diagonal with 12 and 4, 4 comes out of both 12 and 4. So what they're doing here is they're dividing 4 out of each of those to make those become 3 and 1. And that explains this line of work here. What they're then doing is multiplying across, just like we did, but with these numbers that we've reduced, and they end up with 9 and 1 with the negative in front, negative 9 over 1, or negative 9, which is the same thing as negative 36 divided by 4, also negative 9. It does not matter which approach you take. If you multiply and then reduce, or reduce and then finish that multiplication, it's really just a matter of personal preference. Here's 1/3 times 3/8. Again, we could go ahead and multiply right away here. So we've got 1 times 3 in the numerators, 3, and 3 times 8 in the denominators, 24. And then we would reduce that fraction 3/24 by dividing out its greatest common factor, which is 3. And that would make this go down to 1/8. Now the other option is to do what you've seen on the screen here. On the diagonal with the 1 and the 8, nothing's going to come out of those. But on the diagonal with 3 and 3, you could obviously take a 3 out of both of those, which is what you can see they're doing right here, and so they both become a 1. And then we would multiply across, and we would end up with 1 and 8. 1/8 as the final answer. Notice, either way, the solution is the same. Again, it's really just a matter of preference whether you want to reduce after you multiply or reduce first and then multiply. So now they're asking us to multiply together 2/5 and 1 2/3 in example 2, and we're supposed to write our answer in the simplest form. Now, unlike adding and subtracting involving mixed numbers, you cannot tackle these in parts. For instance, if we were doing 1 2/3 times 4 1/3, we can't do the 4 times 1 and the 2/3 times the 1/3 and put those answers back together and say, we're done. It doesn't work that way. What you're going to have to do here is change those mixed numbers into improper fractions where they exist, and then multiply. That's really all you can do here. So right away, as you can see in the first line of work here, they're changing 1 2/3 into 5/3. We've already done that process this year of changing the mixed numbers into improper fractions, but remember, I would do 3 times 1 here, which is 3, and then add the numerator 2, which is 5, and the denominator stays the same, and that's how I get 5/3. So I'm doing 2/5 times 5/3. Now at this point, you get to make that decision, multiply and then reduce, or reduce then multiply. And what the book is doing here is they're reducing, because on this one diagonal, it's very clear with 5 and 5, we would take 5 out of both of those. So that's what they're doing. They're chopping 5 out of each of those and making them both become 1, as you can see here. The diagonal with 2 and 3, nothing comes out of 2 and 3 other than 1, and of course dividing out 1 isn't going to change anything. So they stay the same. Now we multiply across. We've got 2 times 1 in the numerator, 2, 1 times 3 in the denominator, 3, and we end up with 2/3. Here's 4 1/5 times 2 1/7 in the B part of the example. Again, both of these will need to be changed because you cannot work with those mixed numbers here. You're going to have to make them improper. So 4 1/5 got changed into 21/5. 5 times 4 is 20, plus the 1 in the numerator is 21, and the denominator would stay the same. 7 times 2 is 14, plus the 1 in the numerator is 15, and the denominator would stay the same. So we've got 21/5 times 15/7. Well, just like all the other questions now, it's time to make a decision. Do we want to reduce first and then multiply, or multiply and then reduce? I want to reduce first, like the book is showing. So on the diagonal with 5 and 15, we know we could take a 5 out of each of those. That's the biggest number we can take out, so let's chop out that greatest common factor. 5 divided by 5 is 1, and 15 divided by 5 is 3. Now we can also reduce the other diagonal with 21 and 7. I could take 7 out of both of those, which is the greatest common factor of 21 and 7. 7 divided by 7 is 1, 21 divided by 7 is 3. And now that I've reduced everything, now I can go ahead and multiply. Again, we're multiplying straight across here. So I've got 3 times 3, which is 9, and 1 times 1, which is 1, and we end up with 9 over 1, or just 9. 9 divided by 1 is 9. Okay, so now they're throwing a word problem at us, but let's remember that this is in the section about multiplying, so there's a pretty good chance that somehow they want us to multiply to solve here. So let's keep that in mind. In 2001, the car toll on the George Washington Bridge was $6. In 1995, the toll was 2/3 of that toll. What was the toll in 1995? The word of means multiply. That's something you already know because you've already seen it on your reference sheets. We've already talked about it a little bit this year. So that's how we know that this question fits in with this section, because remember, this is about multiplying. We're multiplying really the numbers we have together that aren't the years. Right? 2001 and 95 are years. Those don't really help me. What helps me is that it's 2/3 of the toll, and the toll was $6. So I'm multiplying together 6 and 2/3. Now, some of you might be looking at this top line now and going, well, wait a minute. You just said multiplying, but those all say addition. What they're doing here is they're showing multiplication as a repeated addition, the same way you learned multiplication originally. For instance, if the question was 4 times 3, all right, there's a couple ways they could have shown that to you back in elementary school. Perhaps they showed you some groups of something, let's say marbles. They gave you 3 groups of 4 marbles. So I'm drawing a group of 4 marbles, and then another group of 4 marbles, and then another group of 4 marbles. And you counted up how many marbles you had, and you saw that there was 12 total marbles there. And then perhaps they showed it to you the other way, in that they could have done groupings of 3 marbles 4 times. And you counted up how many marbles you had there, and you still had 12 marbles. And from that, you were supposed to draw the conclusion that 4 times 3, drawn out graphically, whether I do 3 groups of 4 or 4 groups of 3, is the same thing, and the result either way is 12. Well, they're doing the same thing here. They're doing 6 groupings of 2/3, or 2/3 6 times, which they can then add those together using the rules of addition. Now, of course, we could just write 6 over 1 and multiply, which would also give us 12/3 here, which is what we see in the second line of work. It does not matter. Either way, again, shows the same thing. 12 over 3 reduces. 12 over 3 reduces to 4. And so 4 is the answer. Let's put 4 in context. Remember, the question was, what was the toll in 1995? Well, since the answer is 4, that means the toll was $4 in 1995. All right, so let's go ahead and take a look at the check it out examples here. Number 1, in 2002, the fee to park in a parking garage was $4. In 2000, the fee was 3/4 of the fee in 2002. What was the fee in 2000? So this is much like that last question we just solved. All right, it's a word problem, but it's about multiplying, and there's really only 2 numbers in the question that aren't years, $4 and 3/4, so we're going to multiply together the 4 and the 3/4. Now notice I've written 4 as 4 over 1, because again, since this is about multiplying fractions, everything really should be a fraction. And then we've got choices. We can multiply and then reduce, or we can reduce and then multiply. Well, as you can see from the work that's already on the screen, I've reduced first, because on the diagonal with 4 and 4, I could take 4 out of both of those, and they would both become a 1, as you can see here. And then when I multiply, I get 3 over 1, or just 3. So in context of the question, that means the fee in 2000 was $3. The other question here, we're multiplying together -3/7 and 1/8 and writing our answer in simplest form. Well, there's nothing to take out here because 3 and 8 have a greatest common factor of 1. 7 and 1 have a greatest common factor of 1. So we can just multiply. What we want to be cautious of is to make sure that in the end our answer is negative, because as you can see, we have mixed signs here, so my answer should be negative. 3 times 1 is 3, and 7 times 8 is 56, and so we end up with -356.